Welcome, dear students. As the procedure we are following to keep you engaged, we will be first starting our discussion by a simple poll question, and then I will be taking numericals based on polls. Okay, but before the actual test starts, which I will be doing on the using my poll mode, I would be revising the concept. Okay, but before revising, let me first put the obvious question or very obvious question to capture your attendance actually. Okay, so this is basically the poll question to capture your attendance now. I'm launching this poll. Can you see the poll? Somebody please answer. Okay, all right, you are not able to see. Let me try again. Now is it seen? Okay, all right. Okay, let me try it again. Aditya, can you see the poll? Okay, you can see my screen, but you are not able to see the polls. All right. All right, I am facing some issues. I'm waiting for Pille ma'am to join so that she can launch the poll. Pille ma'am, are you around? Okay. All right. Whether the whiteboard is seen? Whether the whiteboard is seen? Can you see the whiteboard? No. Now is it seen? Can you see the whiteboard? Yeah. Okay. All right. So we would be solving numericals on Carnot Engine. Okay, and before we get to the numericals proper, I will be revising few concepts, one or two concepts before we start thing. So what we need to remember is, one is the Carnot engine is an ideal engine. Okay, that is the first point you need to remember. The second point you need to remember that it is a heat engine. So when it is a heat engine, obviously it has to supply certain heat, that some heat has to be supplied, and we need to reject certain heat. Okay, so the Carnot engine, like any other heat engine, would produce work when some heat is being supplied to it, okay, from a source, and some heat has to be rejected. So even if we are talking about an ideal engine, it cannot be that the heat rejected is zero. So the heat rejected is always greater than zero. Please note, even when we are talking about a Carnot engine, the heat rejected is greater than zero. Okay, so this is one important point you need to always bear in mind, that a Carnot engine, it is a reversible engine. Okay, it is an ideal engine. However, the heat rejected will always be there even for the Carnot engine. Then what is so important about the Carnot engine is, it being a reversible engine, its efficiency is independent of the properties of the working fluid, and it depends upon, it's a function of source temperature and sink temperature. Okay, that you need to remember. What is so special about a Carnot engine is, Carnot engine efficiency does not depend upon the properties of working fluid. So any working fluid, imagine, okay, the properties of the working fluid are not going to have any effect on the efficiency of the Carnot engine. So on what parameters would the efficiency depend on? So the efficiency of the Carnot engine would depend upon, one is the source temperature, that is TH, and other is the sink temperature, that is TL. Okay, so whenever you are interested in finding the efficiency of the Carnot engine, okay, we would express that efficiency in terms of the source temperature and sink temperature. Okay, so this expression which I am writing down, this expression gives us the efficiency of the Carnot engine. This expression gives us the efficiency of the Carnot engine, and you see that in this expression, we do not find any term related to the working fluid. There is no term related to the working fluid. Okay, only two terms are there. One is the temperature of the sink, and other is the temperature of the source. Okay, so it's pretty easy. To compute the efficiency of the Carnot engine by simply knowing two parameters. One is the source temperature and other is the sink temperature. Please note that while deriving this expression for Carnot efficiency, this capital T, this T is in Kelvin, it is not in Celsius. Similarly, this T is also in Kelvin, it is not in Celsius. Okay. So whenever we are asked any numerical, whenever a numerical has to be solved, which involves the concept of Carnot engine, okay, and you are given the source temperature and sink temperature, we should always convert the temperatures of the source and sink to Kelvin and then use this expression, that is 1 minus TL upon TH expression, to find the efficiency of the Carnot engine. Okay, so please remember this. So whenever any numerical on Carnot engine is asked, okay, we need to remember that the efficiency of the Carnot engine would depend upon the source temperature and sink temperature. Both temperatures are to be expressed in Kelvin. Number one. Number 2 point, when you are solving this Carnot engine numericals, please note that Carnot engine is like any other heat engine in the sense that it will also reject certain heat. Okay, it will also reject certain heat. Because it is the best engine, it would have the maximum efficiency. Because this is the best engine, it would have the maximum efficiency. Okay, so with this introduction, okay, hopefully I would be able to launch this poll. I'm not sure why I'm not getting that. Okay, I am facing some issues in launching this poll, but I'll read out the question. Okay, you take down this question. Okay, and you have to answer this in the question column. If the problems get sorted out, then we would be also be able to capture this in the uh, poll form. Okay, but till then, okay, you should. The question is very pretty simple. There is a Carnot engine. There is a Carnot engine, and the Carnot engine is working between 30 degrees Celsius, and 800 degrees Celsius. Find its efficiency. The Carnot engine is working between 30 degrees Celsius and 800 degrees Celsius. You are required to find its efficiency. So solve this and put your answers in the question column. Solve this and put your answers in the question column. 30 degrees and 800 degrees Celsius. You are required to find the, when you put your answers, you put it in the form of you include your names, right, and your roll numbers there when you answer it. So send your answers. Yuvraj Singh has answered. Sanket Sanap has answered. Vaibhav Deshmukh has answered. Suraj Bhagwat has answered. Parikshit Pawar has answered. Om Patil has answered. Atharva has answered. Zai has answered. Chinmay has answered. Chinmay Phadke, your answers are not seen. Gunjan Sarode, answer is not seen. Siddhil Jadhav, Roshan Jadhav, Apeksha Patil. See, some students are getting it wrong, and this is because they must have not listened to what I said. I had made a very clear statement when I had asked this question. Okay, but unfortunately, some students are missing this point. One student, Rohan, has got answer 96%, which is wrong. Gauri has got it correct. Praveen has got it correct. Kabir has got it wrong. Om Patil has got it correct. Nikhil Pardesi has got it wrong. Rushikesh Thorat has got it wrong. Pranav Mati. Gaurav got it wrong. Pranav Mati has got it right. Kunal Patil, okay. So you can put down your answers, okay, and I will see it later. But let me show you. Many students have got it wrong, okay, and the reason is uh, they have not listened to what I have said. Okay, I will try to repeat this what I had stated, and this is also Vedant has got it wrong. Okay, so let me not. I have captured that whatever you are written. That we'll see later. See what is our what is. Can you see the whiteboard now? Whiteboard is seen. Yeah, okay, thank you. So on the whiteboard, I had drawn a Carnot schematic of a Carnot engine, and I had shown you that this is a reversible engine, wherein heat is supplied and heat is rejected, and you get work. On the board, you see that I have written the expression for Carnot efficiency. So Carnot efficiency, as I said, the efficiency of the Carnot engine, efficiency of the Carnot cycle is a function of only two parameters. One is the source temperature and other is the sink temperature. One is the source temperature and other is the sink temperature. And that efficiency can be found out by the expression because it's a reversible engine. It is given by 1 minus TL by TH. Now, what is the sink temperature given? The sink temperature given is 30 degrees centigrade. Okay. So the sink temperature is 30 degrees centigrade. So this is TL. Okay, let me write down somewhere. Okay. So TL is 30 degrees centigrade. And I told you that whenever the temperatures are given in Celsius, you need to convert them into Kelvin. You need to convert them into Kelvin. Okay. Similarly, TH is also given in Celsius. So TH is, again, I am expressing it in Kelvin. So 800 plus 273. Okay. So obviously the efficiency would be 1 minus TL, that is 30 plus 273 upon 800 plus 273, 800 plus 273, which is nothing but 1 minus 0.282 or something like that. Okay, so it is approximately 72%, approximately 72%. Okay, 72%. So some students have got it 90 and plus, and some students have got it 20 something like that. So that is because one mistake which is common in this kind of problems is students forget to convert the degree Celsius to Kelvin. Okay, so please note that the major first mistake which most of the students are committing here, which I see in the answers which you are given. Okay, for example, Saurabh has got it 28.3 or whatever. Okay, so this is because you forget to convert this to Kelvin. Okay, so one thing you should do is convert this to Kelvin first, and second thing you should do is that the ratio which you get TL by TH, you have to subtract it from 1. Okay, then you'll get the efficiency. Then you'll get the Carnot efficiency. So this was the first question. Okay, so I'll work out the marks based on your responses in the question column, because unfortunately I'm not able to launch the poll somehow. All right, so the second question is, please listen to this question carefully. Okay, and you will have to answer this. The second question is, there is a Carnot engine. There is a Carnot engine which absorbs 100 joules of heat. Okay, it is a Carnot engine which absorbs 100 joules of heat. 100 joules of heat while working between 30 degrees centigrade and 800 degrees centigrade. There is a Carnot engine which absorbs 100 kilojoules of heat while working between 30 degrees centigrade and 800 degrees centigrade. The question is how much will this engine reject the heat? How much heat will be rejected by this engine? Okay, I'll repeat this question once again. A Carnot engine absorbs 100 joules of heat. A Carnot engine absorbs 100 joules of heat while working between 30 degrees centigrade and 800 degrees centigrade. 30 degrees centigrade and 800 degrees centigrade. I want you to find how much heat this engine rejects. How much heat this engine rejects. Okay, so start answering. Put your answers and put your names and the roll number while you answer it. Okay, so let me see what you get the answer as. So students are writing. Parikshit Pawar has got some answer. Parikshit Pawar has got 72 joules. Atharva Pandit has also answered. Parikshit has got it wrong. Atharva has got it right. Sridhar Katae. Yes. Lucky Singh has got it wrong. Mohammed has got it wrong. Om Patil has got it right. Fatima is wrong. Kunal is wrong. Abhijit is wrong. Suesh is wrong. Pranav Mate is wrong. Vishlesh Girase is wrong. Omkar Fekre is right. Gauri Jagtap is right. Zai is right. Aditya is also right. Saurabh Jadhav wrong. Aniket Kapote wrong. Kunal has got it right. Vinay Shinde is wrong. Yuvraj Singh is correct. Chinmay Fatke has got it right. Sai Raj is correct. Vedant Bokre has got it wrong. Siddhil is correct. Vedant Uttarwar is totally wrong. Abhijit Marathe is wrong. Prajakta is correct. Okay, so what I see is that there are some silly mistakes which students are making. I'll capture that. You can write down your answers. Okay. See, I hope the whiteboard is seen again. You see the whiteboard? Yes or no? Whiteboard is seen? Okay. See, what is given now? The same question. It is basically the same question. Okay, the question is same. That is, the source temperature is 800 degrees Celsius, which is 800 plus 273 Kelvin, and sink temperature is 30 degrees centigrade, 30, which is 30 plus 273 Kelvin. Okay, so source temperature and sink temperature is same, and additional information is given. And what is that additional information? That additional information is the heat supplied. The heat supplied is 100 joules. The heat supplied is 100 joules. Okay. Now, when 100 joules is supplied, okay, we have already found the efficiency of the Carnot engine. What is that efficiency? The efficiency is 72%. Now, what do you understand by efficiency? Efficiency is the work output upon the heat supply. Okay, work output upon the heat supply, and that efficiency is 72%. Okay, 72%. So the heat supplied is how much? Heat supplied is 100 joules. Okay, so of this 100 joules, when the efficiency is 72%, it means that you will get the work as 72 joules. Obviously, yes or no? If you are supplying 100 joules, and the efficiency of this engine is 72%, it means that the work from this engine would be 72 joules. Okay, approximately 72 joules, right? So that being, because the efficiency of this Carnot engine is 72%, the work output of this Carnot engine is 72 joules. Now, if the work output is 72 joules and you are supplying 100 joules, so what would be the heat rejected from the energy balance? It would be 100 minus 72. So this would be, heat rejected would be 100 minus 72. Obviously, because you are supplying 100 joules, of which 72 joules is getting converted to work, it means that 28 joules, it means that 28 joules would be 28 joules would be the heat which is rejected. That is the correct answer. Okay, so the correct answer is approximately 28 joules. Okay, 28 joules. Please note, right? So the students who have got it 72 or 172 or whatever, they have committed a blunder. Okay, so we need to understand this very perfectly, that Carnot engine having 72% efficiency means what? It is producing 72 joules of work of the 100 joules which is being supplied, and obviously the remaining part of the energy has to be rejected. The remaining part of the energy has to be rejected. Okay, the next question. Listen to this question carefully. Okay, I will repeat this question again. The same temperature difference. A Carnot engine operates between a Carnot engine operates between 800 degrees centigrade. A Carnot engine operates between 800 degrees centigrade and 30 degrees centigrade. A Carnot engine operates between 800 degrees centigrade and 30 degrees centigrade. Okay. The question is, listen carefully. Listen carefully. What is the least rate of heat rejection? What is the least rate of heat rejection per kilowatt of work output? What is the least rate of heat rejection per kilowatt of work output? Okay, I'll repeat the question once again. A Carnot engine operates between 800 degrees centigrade and 30 degrees centigrade. What is the least rate of heat rejection per kilowatt of work output? Per kilowatt of work output. Okay, solve this. Nobody has yet answered. Nobody has answered yet. Okay, you want the question to be repeated? I'll repeat. Aditya is asking me to repeat the question. I'm repeating the question again. The Carnot engine, an engine operates between the source temperature of 800 degrees centigrade and sink temperature of 30 degrees centigrade. Okay, an engine operates between a source temperature of 800 degrees centigrade and a sink temperature of 30 degrees centigrade. I want you to find what is the least rate of heat rejection. What is the least rate of heat rejection per kilowatt of net output of the engine? Per kilowatt of net output of the engine. Per kilowatt of net output of the engine. Okay. So Sairaj has got it correct. Sairaj has got it correct. Pranav has got it wrong. Atharva has got it wrong. Sridhar has got it correct. Deepalakshmi is wrong. Aniket, I had already repeated. I will repeat it again. Find the least rate of heat rejection per kilowatt output of the engine. Siddhil has got it correct. Atharva Mahajan has got it correct. Atharva Mahajan has got it wrong. Siddhil has got it wrong. Sridhar is wrong. Yuvraj is right. Aditya is wrong. Tanaya is right. Tanaya is right. You also put your division and roll number there, okay? Yash is wrong. Chinmay is wrong. Abhijit is wrong. Gunjan is wrong. Selva Rajin or Selva is wrong. Pranav Mate has corrected, I guess. Now is right. Rohan is saying something. I don't know what he's writing. Nishant Karamkar is right. Kunal is wrong. Siddhil is right. Ishan Puri. Yes. Okay. See, many students have got it wrong, and the reason is they are not yet answered also. The reason is they have missed a very important part of the question. Okay. Gauri has got it wrong, right. Gauri Jagtap is right. Anupriya is wrong. Durgesh is wrong. Durgesh Virar is wrong. Atharva Mahajan is wrong. Gargi is right. Apeksha is right. Prajakta is right. Kunal is right. Aniket Kapote is correct. Aditya is wrong. Aditya Rawat wrong. Suraj has got it right. Vishal has got it right. Athurva Majan is wrong. Okay, Aditya Handge is wrong. Parikshit Pawar is correct. Vikhyat has got it right. Vinay has got it right. So maybe now you might be sharing answers also, whatever. That is not the issue. Look at this. Look at the question here. Okay. Uh, what is different in this question? What is different in this question? In this question, you can see the whiteboard. Can you see the whiteboard? Can you see the whiteboard? Yes, thank you. Thank you, Raj. So what you see is here heat supplied is not given. Here the partly this question is the same. It means that the source temperature is given and the sink temperature is given, and it is same because for convenience I had kept it same. So the source temperature is 800 degrees Celsius, sink temperature is 30 degrees Celsius, and the other information is that here the heat supplied is not given. Here instead what you are given is the work output. Okay, you are required to find per kilowatt of work output. So for every kilowatt of work output, you are required to find the heat rejected. So the given question is you are given this information. This is in the information given, and you are required to find heat rejected. Okay, you are required to find heat rejected. So now using our basic expression of a heat engine, efficiency of the heat engine, any heat engine would be work upon heat supplied, and this being the Carnot engine, its efficiency we had already found 0.72, and the work is given to be for every kilowatt. So for every kilowatt means work output would be 1 kilowatt. Okay, so the heat supplied, could be 1 upon 0.72. Heat supplied could be 1 upon 0.72. Okay, so that comes to, if you solve this, that comes to 1.39 approximately. Okay, that comes to 1.392. Okay, 1.392. It means that this engine is getting 1.392 kilowatts of heat as an input, of which 1.392 kilowatt of heat as an input, of which 1 kilowatt of which 1 kilowatt is the work output, of which 1 kilowatt is the work output. So the heat rejection by the energy balance would be 1.392 minus 1, 1.392 minus 1, which is nothing but 0.392 kilowatts, 0.392 kilowatts. So the answer is 0.392 kilowatts. Okay, few of the students have got it correct. Okay, how to find it is, we are first finding the efficiency of the Carnot engine by making use of the fact that source temperature and sink temperature is given, which comes to about 72%. Using that expression, okay, and knowing that the work output of this engine, because net work output is 1 kilowatt, okay, we find the heat supply, and that heat supplied comes to 1.392 kilowatts. Because the heat supplied is known, because the work output is known, you can find the heat rejected by the energy balance, 1.392 minus 1. So the heat rejected is 0.392 kilowatts, 0.392 kilowatts. Whiteboard is not seen. Whiteboard is not seen. दिसतोय गर्गीतामध्ये दिसतोय. Okay, so I hope that this is clear to you. Okay, I will take one more question before we end this discussion. One last question. Okay, take down this question. A Carnot engine Sorry, it is not given. Okay, it's not given that the engine is Carnot. Please correct this. Uh, a heat engine. Okay, it's not given the engine is a Carnot engine. Heat engine. A heat engine works between a heat engine works between 300 Kelvin and 1000 Kelvin. A heat engine works between 300 Kelvin and 1000 Kelvin. I will also write it down on the whiteboard because the whiteboard is seen to you. Okay, so let me write down the question. Let me erase this first. Okay, okay, I'll write down the question for you um, so that it becomes clear. Okay, it is not given that it is a Carnot engine. Please note, a heat engine, a heat engine works between heat engine works between 300 Kelvin and 1000 Kelvin. 1000 Kelvin. What is what least? What is the least? It is not given. It's Carnot engine. No? The question is that what is the least rate of heat rejection? Heat rejection per kilowatt of net output net output of the engine. Okay, answer it. Solve this and write the answers. Okay. Question is seen on the whiteboard. Gauri. Question is not seen. Chidman, question is not seen. Okay. Now it is seen. The question is seen or no? Okay, it's not available. Not seen. All right. Let me use some other pen, maybe. Okay, even if it is not seen, I will be repeating this question. Heat engine. Okay, you can take down. I will try to write this out, but you can take down the question. Okay, heat engine works between 300 Kelvin and 1000 Kelvin. 300 Kelvin and 1000 Kelvin. You are required to find what is the least rate of heat rejection. You are required to find what is the least rate of heat rejection per kilowatt of net output of the engine. Per kilowatt of net output of the engine. Okay, you are required to find the least rate of heat rejection per kilowatt of output of the engine. Okay, it is not given that the engine is a Carnot engine. It is not given that the engine is a Carnot engine. Can you see what I am writing now on the board? Yes or no? I have used a different pen. Can you see the board, whiteboard, and I have written something on that? No, it is not seen. Surprising. Okay, answer I will find out. Don't worry. Answer I will tell you. But I want to make sure that you are seeing the whiteboard. Are you able to see the whiteboard? Yugandhara, can you see the whiteboard? Yes, now it is visible. Okay. What I have written is also visible. Okay. Engine I have written. Can you see engine? Yes. So engine is there, and its engine is operating between. Engine is operating between. It is not a Carnot engine. It is not given. Okay. It is not given that it is a Carnot engine. It's simply saying that it is a heat engine operating between 300 Kelvin and 1000 Kelvin. 1000 Kelvin, and you need to find is the least you need to find what is the least rate of heat rejection. Least rate of heat rejection. Least rate of heat rejection. It is not mentioned anywhere that the engine is Carnot engine. Least rate of heat engine, rejection per per kilowatt output. Per kilowatt output of this engine. Now, okay, you can write down your answers in the question column, and I will just put down this question. This question is a bit tricky because here they are not mentioned that it is a Carnot engine. So you can put down your answers, and then you can check your answers with my answer. Okay. So the efficiency of any engine, any heat engine, is work upon heat supplied. Work upon heat supplied. Okay. So the work output is given to be 1 kilowatt, and heat supplied is unknown. Okay. Now it is not mentioned that it is a Carnot engine. However, it is mentioned that this engine has to reject the least amount of heat. So when an engine has to reject the least amount of heat, obviously that engine has to be a Carnot engine. Okay. So though it is not mentioned that the engine is not a Carnot engine, but because it is given that we need to find the least heat rejected, so the heat rejected would be minimum. Heat rejected would be minimum only if this engine is a Carnot engine. If it is any other engine, then the heat rejected would be more. If it is any other engine, the heat rejected would be more. So in this case, though it is not mentioned that the engine is a Carnot engine, but we can use the expression for Carnot engine efficiency because it is asked that you are required to find the least heat rejected. Okay, so that comes to be pretty simple answer now. So the efficiency comes to be 70%. Okay, right, and efficiency is 70%. So this is 70%. So the heat supplied would be 1 upon 0.7, right? The heat supplied would be 1 upon 0.7 because the efficiency is 70%. So 1 upon 0.7 is 1.42, 1.42, and hence obviously because this is 1.42 kilowatts, this is the heat supplied is 1.42 kilowatt, and your work output is 1 kilowatt. So the least heat rejected would be 0.42 kilowatt. That is the answer. So this is the answer. Okay, some of you have got it correct. Okay, thank you very much. So with this I end this test, okay, which was a bit inconvenient for you to attempt because of some issues on my side, because I couldn't launch the poll. But nevertheless, I have the solutions with you, and it was more interactive because I could see who was answering what. Okay, so that way also it is same. The question is not the same. The question is a bit different because in this case, I have changed the source temperature. And here I had also given the source temperature and sink temperature directly in Kelvin. directly in Kelvin. Okay, right? So the answer to this question is 0.42 kilowatts. Okay, so thanks for joining this webinar. Okay, I hope your concepts of Carnot engine numericals, how to solve the Carnot engine numericals, they are pretty clear. Okay, and they are very straightforward numericals, not very difficult. Okay, it involves hardly two expressions to solve this kind of numericals. Okay, but you need to be very clear about what the question is. Okay, thanks a lot.